This video covers 7.4, finding the least common denominator and forming equivalent rational expressions. In this video, we'll cover objective 2. Write a rational expression equivalent to a given rational expression. When we have a fraction and we want to write it as an equivalent fraction, we can multiply the fraction by 1. For example, if I take 3/4, I can always multiply it by 1 and it keeps it unchanged. But sometimes we specify the denominator must be something like 24. So whatever it takes to get 24, we do it top and bottom. 6 times 3 is 18. So writing these in their unsimplified form so that we can compare them or add them to other fractions with that same denominator. So it's very important. What we do to the bottom, we must do to the top. So we're going to ask ourselves, what do we want? What denominator do we want? And what do we have? We have 4p times p minus 2. 4p squared minus 8p factors as 4p times p minus 2. So we're trying to figure out what it is that we're missing so we can put it in the top and the bottom. We multiply by 1, which means that whatever we do to the bottom, we also do to the top. So I look it over here. What do I want? I want 16 and I have 4, so I multiply by 4. I want p cubed. And I have p, so I multiply by p squared. I want p minus 2, and I have p minus 2, so I'm done there. So I do it in the top and the bottom, which gives me 12 p squared. So now we've written 3 over 4p squared minus 8p with that specified denominator. So again, it's all about saying this is what I want and what I have, and you figure out that we're missing a 4p squared, so we put it in the top and the bottom. Whatever I'm missing, I put in the top and the bottom. I multiply out the top, but not the bottom. So here's a practice problem for you to do. I encourage you to press pause on your video and try your best to work it out, and come back when you're ready to see the problem worked out. All right, now that you've had a chance to work this out, what you have, or what we have, is a 3 times, we have a 3 and an x times an x plus 2. And I see what I want to have is 12x squared plus 8x, which has a 4 and an x plus 2. Boy, I'm really messing this up here. So we really have an x and a 3x plus 2. And over here, we take out a 4, and we're left with 3x plus 2. All right, so what I want is to have a 4 and an x and a 3x plus 2. And what I have is an x and a 3x plus 2. So that means I'm missing the 4. So I put it in the top and I put it in the bottom. And once I put it in the top, I get 28 over 4x times 3x plus 2. Now I have what I wanted to have as my denominator, and I have a new equivalent fraction. Example 5. We want to have an x plus 1 an x plus 2, and an x minus 2. But what we have is an x plus 2 and an x plus 1. For the first fraction. My second fraction has x minus 2 and x plus 2. So I start with the first one. I have a plus 2 and a plus 1. You ask yourself, what are you missing? Well, I look over here and I want to have a plus 1, a plus 2, and an x minus 2, so I'm missing the x minus 2. So I put it in the top and I put it in the bottom, which results in multiplying out the top for x minus 8, keeping the bottom factored. 9 over x minus 2x plus 2, I have a minus 2 and a plus 2. I want to have a plus 1, plus 2, and minus 2, so I'm missing the x plus 1. So we multiply out the numerator, but leave the denominator the same. Don't multiply out the denominator. So there's our two equivalent fractions with the specified denominator. You know what? Now we're ready to add. We've got the same denominator. We're ready to add them or subtract them, whatever is called for. So that's all the hard work. Getting the denominator is the hard work. Adding it's the easier part. All right, this concludes the video on 7.4, finding the least common denominator and forming equivalent rational expressions. Objective 2, write a rational expression equivalent to a given rational expression.